Morning, droidcon New York, and a much cooler morning it is too. How y'all doing? Doing good? All right. I like it. I like it. I appreciate it. At least the party was not too good, but just good enough. Yeah. All right. All right. My name is Huyen Tue Dao. This is going to seem really familiar because I was talking about custom layouts this year, and I'm back. We're going to dig a little bit deeper into custom layout this year and talk a little bit about subcomposition. But I do want to talk about some different aspects of custom layouts because I feel like I've been a custom view, custom layout person my entire career, and I'm just trying to get people to use them. And so with my overenthusiasm, let's go ahead and get started. If you did see my talk last year, it's going to be a little bit repetitive, but we're Android people. We like a life cycle. We like phases. And so I always like to start with talking about kind of the basis on which we're building. So in Compose, we have three phases that take our composable functions 2 pixels on the screen. All right, now the first of those phases is composition. Composition is basically all of your @composables annotated functions. And what happens is composition is how Compose determines what is on the screen, like what specific components, containers are actually going to be showing up. Now, the way that this happens is that all of those @composable annotated functions of yours, when they get invoked, when they get called, they will emit, they will create emissions. And these emissions are basically nodes that are successfully added to an in-memory tree representation of your UI. So, your containers, children, all that. So it is through composition, it is through your functions that this representation is built. So once we know what is on the screen, we need to know how big it is and where it's going to be. And that's where the layout phase takes over. There's 2 parts to it. Number 1 is measurement. Old school view people, this will sound a little bit familiar. In measurement, elements will measure the children and determine their own size. This only happens once per composition. And then after measurement happens, then we can actually place those elements where they actually find a spot for themselves and their child elements on the screen. And then finally, drawing happens. We're not going to talk about that at all, but that's how we go from @composables to pixels on the screen. Now, a really cool part of this is that, as we're doing Compose, we're learning a lot, these days and talking quite differently about state, right? You've probably read a lot of great blog posts about state hosting and how you can very cleanly, kind of specify and, kind of locate your state so that you have good state hygiene. And part of the value of this is being able to skip compositions, right? We've probably heard, too many compositions will be bad for performance, bad for this. So the idea of skipping is not just kind of a switch of like, composer, don't recompose. There's actually a concept called phase state reads. So each of these phases is going to read some kind of state. If the state within a given phase does not change, that phase can be skipped. So it's not just like draw or redraw. I can actually probably skip composition and just do measure, or skip measure and just do placement. It's that level of granularity. And so that's why I think, especially in Compose, I know the custom view system is very traumatic for some people. I totally get it. And we've developed this kind of reaction to be reticent about doing it. But I just love this because it kind of goes along with this whole different, this whole modern UI toolkit, right? It goes along with the things that we do every day in just kind of out of the box components. State hygiene, state hoisting, knowing, how to kind of structure our data so that we can kind of very cleanly, utilize Compose. But now we've got this like kind of fine-grained level as well, and I think that's really cool. I want to show an example of this. Now, it's not just good for different reasons, like for performance and everything, but I want to talk about some non-performance reasons why it's kind of nice to be able to use components like layout and subcompose layout to actually build components. Actually, I want to go ahead and go into some code right now and show you. So if you haven't jumped on the custom compose layout train, I understand. Again, as someone who is like a big nerd about custom stuff, I know like I might be talking and it might seem like a golden hammer where I'm trying to nail down everything with it. Anyone who's worked with me before, please raise your hands. You can ask these people. I really like custom views. They know. They probably have heard just me talk about it all the time, but there's a legitimate reason to do this. And I'm going to show you this. Now, if you went to my talk last year, it's going to look a little bit familiar. Some people I asked who worked with me and they kind of only just raised their hands. That might just kind of show what it's like working with me. So I apologize to my past and current coworkers. So let me go ahead and start up this app. So this is, I'm going to start off with a scheduler that I wrote, and I did talk about this last year. Oh, it's live, so I have to wait. Come on, Yankat, load that app up, please. Load it up. All right, here we go. All right, so this is schedule app. I talked about this in depth last year, but I have basically, a series of classes which I have rendered as one of these little blocks. And I kind of went through last year, like how I did it as a row using the out of box component and also as a custom implementation. So if you didn't see that, no problem, no hard feelings. I do want to show you though the value of custom implementations by opening up Layout Inspector. Y'all in the back, can you see okay? Like, give me a thumbs up if you can see in the back okay? No? Okay. Let me see what I can do about that. Okay. All right, it's okay if you can't really see the UI, but I'm going to open this up. Okay, so what I have here is a bunch of session composables. So each of these classes, my fitness classes, because I'm a big gym rat, so of course my schedule app is like, fitness schedule. So each of these is a composable. And these are my session composables. Now what happens is I also have, I'm going to zoom out again, sorry, is I also have this slider that is DPs per minute. So this is a schedule, right? So the x-axis is time. And so I have some sense of density resolution where I have some number of DPs that is used to render each minute. I couldn't think of a cuter way of saying it. But as I move this slider, you can see that the number of DPs per minute is changing. So my session objects are widening and narrowing. Now what you can see down here, if I can pull it up a little bit for you, is that if you've looked at the layout inspector, it actually shows you recomposition counts. So, oops, I just reset them. That's wonderful. So this column, I know it's hard to see, but the leftmost column is actual compositions. The right column here is skipped compositions. Now I'm going to go ahead and move again. And you can see that with my row-based layout here, you can see all of the white numbers. That's that left column. These are all the compositions that are being done as I'm sliding this back and forth. And you can see they just go up tremendously because as I'm moving this slider, everything in this top row is getting recomposed. But if I go down to my custom layout, look at that. They're all being skipped. And I just think that's so powerful, right? If you have a view like this, which is just churning through, and I'm getting hundreds of recompositions in just a few seconds, you can start to see like how valuable this can be. And yes, we shouldn't, you don't worry about like one extra recomposition, don't pre-optimize, yes. But it is a really powerful tool. And I just want to emphasize that with this. So it isn't just performance though. And I kind of want to go through again and talk about layout real quick. So I'm going to go ahead and open up one of these. I'm going to open up my layout. So this is my custom layout for this scheduler. Now I mentioned those 3 phases, and what I love about doing custom composables is that you can actually see the 3 phases, or locate them rather, very easily in the layout composable within the library. If you're an old school view person, it will kind of remind you of on measure, on layout, on draw. So when you're doing a custom layout, you're going to see the 3 phases in these sections. So there's a content slot, just like any of the other slot APIs that we're used to now in Compose. Composition is basically all the stuff in here. It's me just saying, okay, here's literally just a bunch of stuff that's going to show up on the screen. Now, layout, the composable layout, also includes something called a measure policy, and this describes how you are going to measure and place your children. And so what you get is, as parameters to this Lambda, are a bunch of measurables and a bunch of constraints. Constraints are basically just a min and max on width and height. And they're determined by, the parent of this component. So I can actually see where the measure phase happened. It's really just whatever's inside this top level measure policy. And you can see I'm doing a lot of math here with like pixels per minute. And when you get this list of measurables, that's actually coming from your composable. So I mentioned earlier that when your composable are invoked, these little like emissions get emitted, right? So those get turned into measurables. They're measurables because they are already to be measured, but they haven't been yet. And so usually what you do with a custom layout is you do some calculations, figure out like how big you want them to be. There's a lot of math in here with time. And then eventually I'm going to build some constraints that allow me to set a min and max width or a fixed width, whatever it works. And then I'm going to measure the measurable. What I get back from measuring a measurable is a placeable, and a placeable is something that's ready to be placed. And so way down here, there is this function called layout. It's the layout function inside of the layout composable. It gets confusing. But this inside of this lambda here is actually where placement takes place. And that is where I'm kind of doing all this, like actually specifying X and Y, and that's it. Now, this isn't as sexy as, just out of the box containers with like modifiers and stuff. But I would argue that actually for something that is semi-complex to very complex in terms of layout, it's clear and it's very controlled. And the reason that this works and my row was very not performant is because of phase state reads. So I have a bunch of calculations. I have some state here or there that I'm reading. If I look at the row version, and with row, everything in a row is laid out consecutively. So what I had to do non-consecutive class times is actually add spacers, right? So, I've got a 30-minute gap, so that's a spacer. That spacer is X number of picks or X number of DPs, and that's how I did that. All of these calculations, they're really measure layout calculations, right? But it's all happening inside of this row. It's all happening in composition. So that's why I had all those recompositions, because every time I'm changing variables in this code, every time this is getting recalculated, this is still composition. There's not really a way for you directly inside of a row or a column to access the layout measure passes. There's a layout modifier, but it works in the same principle as a custom layout. But that's why this can be very powerful. Yes, it's really great to have all this logic, but if we just shifted things around, we could get that wonderful, wonderful benefit of skipping recompositions. So that's not the only reason to, use custom layouts, and that's not the only benefit you'll get. So I want to run a different example for you to show where this might also be helpful. So if I go back to my sample app, okay. All right. So let's say that I'm writing, all right, there we go. Hold on. There we go. All right. Now say I'm writing some kind of just, we've seen this view 1,000 times, right? Like a detail view, it's got a hero image, got some text. Okay. Now say I'm doing that and say this is some article that I'm pulling out from somewhere. And I've got, some actions that I have on it, like maybe favoriting or sharing. All right. I have this. It's very simple. It's a box. I've got a row of actions and I shove that row down to the bottom of the box. Looks great, right? Well, I actually cheated a bit. This is not how the comps look. What my designer actually wanted me to do is to align the middle of those buttons to the bottom edge of the hero image. It's very like Material 1.0, but that's what I got. Now, how would I actually make this work, or how would I actually implement this to make my designer happy? Well, if I go ahead and let's comment out this. So this is that version. How about I do something like this? All right. Oops. Something like this. Okay. And is it still? Oh, okay. Why? Oh. Okay. Sorry. There's a lot of errant comments somewhere. Oh, no. There is a comment tag somewhere that is interfering with this. Oh boy. Oh, wait, there it is. Is that it? Okay, there we go. There we go. All right. So I bet that there is somebody out there who has done this or seen code like this. This is not a judgment call. This is just a statement of fact. All right. So when I'm trying to implement this layout here, okay, I'm going to zoom in. All right. How would I do this? How could I shove these two buttons so that their vertical middle is aligned to the bottom of this image? Well, how about I just add some padding? Padding is pretty simple in Compose. And to do that, I would maybe need to add about as much padding as the image, minus a little bit of an offset to center it, right? So I need to know the height of this image in order to, implement my comp properly and make my designer happy. Well, how can I do that? All right. So I might do something like this. All right. So what I have here is a local variable. I have some state, all right, and it's called image height. So what I'm doing is down here for my image, I'm using on globally positioned, which is a modifier, and this callback happens every time that composable is positioned. It returns this thing called layout coordinates, and I can get both the screen coordinates and the width and the height of that thing from it. I'm assigning it to this variable, and then I'm going back here. Here's my state again, and that state is being read to calculate something called action row top padding. And then I take that action row top padding and I put it on top of my row. And if I rerun this, oh, I was there. And I open my article back up. Hey, look. Oops, sorry. Translate inspector. There we go. Hey, look, it worked. My buttons are aligned. That's great, right? Fantastic. Not so much. So this is a very straightforward way of doing this, but I will actually tell you that this is disrecommended, and we'll get into why. And in fact, it's not just me just like being mean about it and being like, oh, don't do that. It's actually in the docs. If you go to the documentation for the Jetpack Compose phases, and you go down here, it talks about something called cyclical phase dependencies. And if you look at this example, it's basically the example I just showed you with an image height. I'm measuring an image so that I can position something else and using basically some dynamic state. So cyclical phase dependencies. So what's happening here is that I'm actually delaying when my layout is fully complete. And I'm causing a dependency between cycles, between frames, between individual compositions. So if we look at this chart, what's happening is here on the first frame, that initial composition, right? I'm laying out, that image and everything around it, and I'm taking that height of that image from my on globally positioned modifier. I'm updating the value of this local variable or local state image height pixels, and then I have to wait. I have to wait till the next frame, and which is going to happen really quickly because what's happening is this state is being updated, so it's going to recompose that layout. And then finally, when I get to this second frame, when I have that image height, populated, can I actually position whatever, that dependent composable is? And now basically I'm saying is, okay, I always need an extra frame to, lay out my layout. And okay, that doesn't sound that bad, right? I just told you that, you shouldn't really sweat having an extra recomposition here or there. And yes, in isolation, this is not a big deal. But there's a reason why this section of the docs exists, and I'm going to show you why. All right, I'm going to go through a different example. Let's go here. So let's say that I'm building a kind of like a magazine app or some kind of like really, artistic content, and I have something like a grid system, right, where I have like a number of rows and columns, and you generally try to align content within, some kind of number of rows or grids, like in an aesthetically pleasing way, right? And say like that's the design system of my company, and I'm writing some primitives, some canonical layouts that can help, position content more easily within this grid system. I might do something like this. So this top section here is like a horizontal division. It has like a section that is 3 columns wide, and then the second section is like 2 columns wide to kind of align things to the grid, to the columns in that grid system. And then this block here with the orange and the yellow, that's a vertical division where it's basically the same concept but with rows instead of columns. Okay, that sounds great. Not too bad. Now, how did I implement this? Okay, if I open this up. Okay. There we go. Now, I might implement something like this again if I use that dynamic, state to say capture if I was doing the horizontal one, right? Say I like measure the width and I just calculate what more or less like 3/5 of that would be and like 2/5 of that would be, and use that to basically size like 2 boxes that can hold that content, but just have it sized directly to align with the grid system. Okay, that seems fine, right? There's nothing too threatening about that. And yes, if I put content inside of these 2 boxes right here, it'll take an extra frame to fully complete. Okay, that's not so bad. But what if I nested these? I mean, they're already nested inside of my example. But especially when you're building canonical layouts, reusable components, reusable layouts for a design system, for your company, just for yourself as a toolkit, you may not know how deep the nesting goes. I mean, this comes up, especially if you're doing stuff like I'm working on server-driven UI at my work. A lot of the times, I don't actually know at compile time what a layout looks like, but I build components that are meant to be flexible and that can just, be generated from some Markdown, some JSON, something, right? So it could be that this is nested over and over and over again. And what happens is that offset of 1 frame becomes a multiplicative problem, right? Because if these are all using that same technique to lay out, then I'm continually adding or multiplying how many extra frames are needed, which can be bad. Anybody here like paparazzi screenshot testing? I know J-Rod's over there. All right. So this is actually a problem I ran into where, okay, you have to trust me. I swear, this is these are real screenshot tests. So say I have this layout, it's double nested, right? I have two layers of that dynamic state, right? Seems fine. If I just go to a third one, this box in the upper right corner, there's actually supposed to be two more levels in there. It's missing. So the way that paparazzi works is that, well, originally it kind of just took a screenshot of the initial composition. John has updated it so that there's a little bit of a buffer, which I think it waits for like maybe a buffer of two frames before it takes a snapshot. And I know, like, okay, well, why can't, hey, JRod, can you like make it three or something? That's not scalable, right? Like, again, if you're using these in like very base canonical components, it's not going to scale. And so this is not really a performance thing. It's actually affecting my tooling. And it actually came up like for me where, oh, I can't actually use paparazzi testing right now because we need to kind of change how we have implemented these layouts. And you can kind of see where it's not just about, some nice theoretical like idea of what a layout should be. It's actually getting into productivity. And actually, just to show you, if I go back to my composables where I actually implemented all this, if I open up the previews for this, you can see here that I actually have a double and triple nested versions of these on the right. They don't even render in previews. And this has also been a problem I've seen as well. So yes, it doesn't matter maybe like for your user that has downloaded a triple, quadruple nested grid, but you kind of see where if we're starting to kind of bend away from how Compose is built and what it recommends, it actually starts showing up and it becomes not a performance problem for your app, but it becomes a performance problem for you because you're losing this tooling. You're coming across these different things. You won't be able to test regressions as well. So that's kind of like my motivation for just telling you this. And again, if I just want to hammer it home, the docs have this really great statement, I think, that also is, again, kind of going more like highfalutin with it, is that, with Compose, one of the really great things about Compose over the old view system is that the old view system, right, every little component had its own little state. It was its own little state machine, its own little world, right? So you'd have like checkbox and text bus and another text input and maybe a button here and maybe like, I don't know, like a drop down over here. And we would have to like write these UIs that coordinated all of this state, right? And I don't know if any of you have written like a really complex form like UI, that was awful, right? Because you get a lot of incoherence happens really easily when you're trying to coordinate all of the state. So with Compose, we've gotten really used to this idea of like example, like unidirectional data flow, where we want as small as possible a single source of truth that is the representation of the state of our UI, and we just want to be able to pass that to a UI that just barfs up a designer-approved, pixel-perfect representation, right? So this idea, this kind of narrowing of that, surface area, that state surface area that our UIs depend on is a great idea. And I would argue, and I suppose I'm not arguing this, the docs are arguing this, is that same principle should apply even within an individual layout. And so, yeah, the general principle here, quoting the docs, is to have a single source of truth. You hear this all the time, for multiple UI elements that should be measured and placed with regards to one another. These elements have relationships, and so we should have a single source of truth that is able to dictate that relationship and allow them to act within that relationship. And I mean, I'll just tell you that if you're a person that actually does care a little bit about what the docs say, the idea is that you can use a proper layout primitive, maybe that's box with constraints, or create a custom layout so that that single source of truth that can be preserved. And it literally just says introducing a dynamic state breaks that principle. So it's disrecommended. And I know like on size changed and on global layout coordinates is really convenient, but it can cause problems. So I wanted to show also really quickly, like if I just have, so box with constraints is a great option, and box with constraints actually is something that uses subcomposition in the title of this talk under the hood. And if I just change my implementation to be box with constraints, so rather than having a dynamic state, I'm actually pulling out max width and max width in this case, or max height, which are things that the box with constraints provides. And it's actually providing it in sync with the composition phases so that you don't have to delay another frame. I'll just show you that, hey, look, all the previews work. Isn't that nice? So it's kind of amazing, right? That if we just kind of, again, just like everything else, whether that's, again, good state hygiene, just following good practices, the benefits just kind of pop up. And so I would encourage you to, even though it is different, they were intimidating in the view system. It's a really valuable toolkit to have in your bag when you're doing UI in Compose. All right, so I do want to talk about subcomposition, which you've probably heard of it. And so I encourage you very much to look into custom layouts. Subcompose layout is going to be like a 5%, 3% of the time tool that you're going to use. But I actually had to use it for work. And so I just think that just having it in your mind and understanding how it works actually reinforces, the lessons of composition phases and why this is important. So I've got another demo for you. Okay, and this is maybe something resembling I actually did at work. All right, so let's pretend that I have some content here. So let's say that, and this is actually, so if you're in a position where your UI is, as I may have like intimated, not all known at compile time. Like maybe, for example, you're doing SDUI like me, or you just have like some other module that's maybe generating composables that are consumed by another element in your app somewhere. You might run into something like this. Let me change that so it's more interesting. Sorry, 1 second. That's not my example. All right. Oh, wait, sorry, wrong screen. That's my bad. All right, I'm gonna make this more interesting by opening up a different file. Opening up a different file. Okay. Okay. Pretend that there's a lot of text here. So let's say that article UI that I had was actually kind of dynamically generated somewhere. Maybe it's a different module in my app. Maybe, I don't know, like, again, like if you're like an SEUI person, maybe you got some markdown and that's like something that was generated, right? So I don't actually have full control of that UI, of that composable that's coming in, of that content that's coming in. In fact, I might not even know what's in it, and I might not, and I wouldn't be able to conceivably break open that composable to see what's in there. I really want to open this file. Oh, it really doesn't want me to open that file. Okay. So, all right. Okay, I'm going to vamp a little bit and talk to you. So imagine that that's happening. And then imagine that also I'm doing a separate interface that ingests this content from wherever and adds some extra UI on top of it. Okay, here we go. And I'm going to change this so it's just a better example. Okay. So I have some content that's dynamically generated or pulled from somewhere. I don't know. I can't actually kind of intervene with that particular UI. I don't have a lot of coverage to it, but I have to lay UI elements on top of it. So it might look something like this. Okay, here we go. That's better. All right, so I have this content that was from earlier. It's generated by some other part of my app. I have this reader screen that has a toolbar at the bottom that has some additional actions on it, okay? So I have a couple things going on here. So I have this content, and if you look at the composable itself, okay, I have this composable, and I don't have like concrete composables. I have slots. And again, I have to be able to, for example, for this content, because this content scrolls, I don't want it to actually collide with the bar down here. I want to have enough space. So how do I do that? Well, I can't just pick apart every single composable that comes my way, but maybe if I work with a person working on that module, maybe I can add in or require a parameter, have some kind of lever that allows me to control the padding right here, yeah? And how can I give it sufficient padding so that I know that this content, which again, I don't control, other than having this one little lever, avoids the toolbar? Well, I can measure the toolbar, maybe using dynamic state in this case. And then what I can do is like using that bottom bar height measurement, I can create some content padding. And then when I actually invoke that content composable, I can pass it this content padding, and then it will take that into account so that it can render correctly. The background still goes all the way down, and I'm able to clear that toolbar. So I already just spent a bunch of time telling you, oh, don't do dynamic state or don't incur cyclical phase dependencies. It's not great. It's bad. But what can we do instead? So what's really interesting is that in this case, a lot of times when you go to custom layout, what's happening is that you have a layout, a child that whose layout, whether that's measuring or measuring or actually placing, depends on another child's layout, right? Like if this thing is like 80 pixels tall, then this second thing has to be starting at, like x equals 80, right? So the layout depends on each other. What happens is sometimes you can have one child's composition, whether it shows up or not, and how it shows up, depend on another child's layout, which is what I have here, right? I have this content and I have this bar. I want this content to pay attention to the composition of that bar, because what if I told you that bar was optional? It can show up or it cannot show up. It could show up in different forms. I just slid in a different kind of composable there, right? So a lot of things can happen, and I need this composable in the back to be able to position its elements or add padding or something that can avoid this. And as you can see here, like this is actually something I did where the bottom component actually was also transparent. So I had to make sure that the background, that the behind composable went all the way to the bottom, but still left space. So this is where subcompose layout can come in. So what I have here right now is, of course, the cyclical phase dependency version where I'm storing something in a local state, in a state variable. And again, that would actually, again, make something like this where if I'm trying to do screenshot testing on this kind of mechanism where I'm dynamically loading content, that makes it a little bit harder. It makes previewing it a little bit harder. So what can I do? All right, well, let me go into my reader and let me bring you up another version that is done a little differently. And the kind of interesting thing is like, no, you don't need to use this a lot, but it's not that bad when you actually need to. All right, so here's subcompose layout. Okay, here it is. It looks a little bit different than the primary layout composable. It has one less parameter, and it does have a measure scope, but its measure scope looks a little bit different. And here's the actual signature. So it has just a measure policy, and it doesn't actually return measurables with its constraints. And that's because in subcompose layout, it is your job to actually initiate composition and to actually generate those measurables yourself. And so for that reader, let me pull it up again so you can see what we're working with. Okay, so I've got some content. Okay, I've got this content. It's filling up the entire screen, and I've got possibly, optionally, this kind of bottom bar at the bottom. Okay, so I'm going to go through the subcompose layout. Okay, well, I know that this whole component fills up the whole screen, so easy. Width and height are the max width and height. And I'm going to come up with some constraints for all of these components. So all these components more or less will take up the whole width. So the min and max width are the same, and I'll let each component more or less measure itself to how high it wants to be based on its content. So that's what I'm just defining with these constraints. Okay, here comes the fun part. All right, so with subcompose layout, instead of just having one composition phase, one measure pass, and one placement phase, you can actually interleave them for groups of composables. So what I want to do is I want to compose this bottom bar. I want to measure it. Hold on a second, use that bottom bar measurement and feed that into the composition of this content back here, right? So that I can add in that extra padding. And I want to be able to do that all on the initial composition. Can I do that? Spoiler, yes. So how do I do that? So first, I need to generate my measurables. I need to compose that bottom bar, and I do that right here. So I have this bottom bar. It's a parameter. It's a composable parameter. And so what you do is you call this function subcompose, and you pass it a slot ID. This could be an index if you're doing something like lazy layout. It could just be an enum in this case, where I have very straightforward, like groups of composables that I'm composing. And so if that bottom bar parameter is not null, if I have a bottom bar to compose, I will pass it into subcompose, give it a slot ID. Otherwise, it returns an empty list. Subcompose can always return multiple composables. I've never had it happen, but it's possible. So that's why it's a list. It's really one thing, but it's a list as a return type. All right, so now I've created my own list of measurables here. I'm going to go through and measure them to get my placeables, and then I'm going to stop. I'm going to be like, all right, how big are you, bottom bar? So I'm going to go through this list of bottom bar placeables. There's just one. So the max is just the height of that one. No biggie. And then I'm going to go switch over and actually compose the rest of this content. So I have here subcompose. The slot is the main content slot. I'm taking that content padding. And it's interesting because inside of subcompose, usually when you're in layout world, you're talking in pixels. But when you're using subcomposition, you kind of phase back into compose world. So here we have DPs. And I'm actually, again, invoking this content, which is itself a composable. It's a composable. Sorry, you probably can't see it in the back. And I'm passing it that parameter. And so what happens is this is actually composing it and providing it. And I can show that real quick. Where is that article? Okay. Here we go. So you can pay attention to this now. So this is what is ending up in there. It could be any arbitrary composable, but this is the particular composable that's coming in right now, and it has that content padding. So if I go back to reader, so that's what's happening. So now I've composed it, I've got measurables, and now at the very end, now that I have everything measured, I can place it. And we run this to show it should just look the same. Oh, okay, this is another good thing. So previously, because I was using that dynamic state, I had to actually add in like extra arguments, right? Because I have this like extra state that needs to be fed, I had to actually add in an extra parameter to my original reader implementation. Let me show you that real quick. If I go up here, I actually, in the parameter list of this bottom bar, I needed to be able to give it a modifier because I needed to stick that on globally positioned in there. And so now that I'm using subcomposed layout, I don't need that extra modifier anymore because now I can just directly create the entire composable with its own modifier here. So the code actually has gotten cleaner because I'm not actually kind of spaghetting around and trying to, save state manually in different places. There's a single source of truth, so things can be a little bit cleaner. And then I'm going to run it, and it's not going to be an interesting demo because it works just the same. There I have, again, my content in the back is very nicely rendered all the way down to the floor, but it is leaving that room for the ticket. All right, so this is not something that you're going to use every day. This is not going to be something that you might use every year, but I think there's a lot of things going on here, right? Having this tool in your pocket allows you, again, to be able to handle situations like this. And I know, like, a lot of times I feel like I look at, like, compose, like, examples, and they're very simple. And so things like this just seem like really out of left field. But as, especially if you're at places, again, where you have your own design systems and you're trying to build toolkits, having this level of flexibility to create extremely lean, extremely performant base layers, the high tide lifts all boats. The more efficiently and effectively you can create these kind of canonical layouts, your base layouts, things that get reused, like the less baggage you're giving to everybody else. And I think that's really important. And it is a good exercise in understanding, again, how Compose works and seeing the full power of it on all these different levels of granularity. But I would also say, like, don't forget that box with constraints exists. Like, that's also very valid. If you are using this, and this is kind of like a side rant for me, box with constraints is built on subcomposed layout. I would be very careful when you're building layouts. If you put in something like intrinsics into your layouts, wait, this is the wrong one. Sorry. Nope. Yeah, intrinsic max. Be very careful of using this intrinsic here. Let me see if I was. This is a problem I've seen where, actually, hold on. With intrinsic sizes, with this, actually, this is what. Be very careful using intrinsic size when you're using subcomposed layouts and when you're using with box with constraints. And I think this is something that people come across, and then so they stop using box with constraints. Intrinsic size is a very, very, very specific tool in the toolbox. It actually is explained in the docs. And there's this really great example of, say, like 2 text boxes, and you have a divider, right? And if you kind of use traditional like wrap content, this divider ends up being way too long when really what you want is something like this. This is intrinsic sizes are very specific to this kind of use case where you know explicitly what the children in a layout are and you want something very particular. I would say, like, don't use intrinsic sizes if you're building canonical layouts, if you're building something that's meant to be used, because it will actually error. I can't get it to error, but I swear to God, it does error. But yeah, just be careful with that. Box with constraints is awesome. But yeah, I would, again, encourage, like, that even though this is something you're not going to use every time, please, like, look into it, understand the concepts, and just know that, with Compose, we don't have to be afraid of custom layouts and all these kind of, like, more complex things, because in a lot of ways, it is just more composed, right? It is, again, trying to define things down to a single source of truth, trying to narrow that state space, and to be able to create very complex layouts and to create them efficiently. So have it in your toolbox. I really appreciate the time. And yeah, have a really great rest of the DroidCon New York. I'll see you guys.